let's look at an example question where we could use proportionality for a more efficient alternate solution. So here's the question. If a man walks at 10 kilometers per hour, he reaches 15 minutes late to his office. If he walks at 15 kilometers per hour, he reaches 10 minutes early. Find the distance from his home to his office. Now, there are many ways of doing this, but let's just look at what we would traditionally do and then let's look at an alternative. So traditionally what people would do is, when you get a question like this, uh, you need to use some basic algebra and solve frame an equation, solve it, and use the solution to get the answer, right? So to have an equation, what can you equate? What information is there that will help you put something on the LHS and something on the RHS, and then put an equal sign in between? That's usually the focus with many of these word problems. So here, two different cases are given. What is same about them is the fact that the distance is the same. He's going from his home to his office on 2 different days. That's basically what happens. So you'll be equating the distances in both the separate cases to get to an equation, and then you'll solve it. So the way to go about thinking is, you know, what if he wasn't 15 minutes late or 10 minutes early? Imagine a different day when he's reaching right on time. What would be the duration of the journey then? On a day when he's neither late nor early, that is something that I'm going to assume as t. So it's basically normal duration, neither late, neither early, not late, not early. So I'm going to assume that is t. So in that case, on this first example, he has a speed of 10 and a time which is 15 minutes more than that, t plus, which is 1/4 of an hour. 15 minutes late means he took 15 minutes more than he should have taken. T plus 1 by 4 is the time, and the distance basically the product, so that is going to be 10 into t plus 1 by 4. In the second case, he has a speed of 15 kilometer per hour and he reaches 10 minutes early, so he takes 10 minutes less than what he would have taken normally. That would be 1/6 of an hour less, so t2 is t minus 1 by 6. And so the distance, according to the second piece of information, is 15 into t minus 1 by 6. And we're referring to the same distances both times. So you can equate it and you can solve for t, and using the value of t you can find the answer. So you'll have 10t plus 2.5 is equal to 15t minus 2.5, which gives you 5t is equal to 5, t is equal to 1 hour. So his normal duration, where he wouldn't be late or early, would have been 1 hour. And you can just substitute this value in either the LHS or the RHS to get the distance. So here it would be 10 into 1.25 hours, which should be 12.5 kilometers, and that is basically the distance from his home to his office. This would be the traditional way of doing it, where we just figure out what can we equate using minimum number of variables, solve for the variable, interpret the value of that variable to get to what you need, which is the distance. Traditional approach. But what else could we do? What's an alternative? Let's see. So the thing to note here is that because the distance is constant, we can apply inverse proportionality, speed inversely proportional to time, right? The speeds given are 10 and 15, which are in the ratio 2:3. So the time should be in the ratio 3:2. The first time when he's 15 minutes late, he takes a certain amount of time, and the second time when he's 10 minutes early, he takes less time, and these two times are in the ratio 3:2. And from here you can simply say, what is the difference between being 15 minutes late and being 10 minutes early? That's a total difference of 25 minutes, right? So you're looking for two numbers in the ratio 3:2 which differ by 25, and at this point you can directly say that this is 75 minutes and this would be 50 minutes. And if you can't, you can simply write 3t minus 2t is equal to 25 minutes as mentioned here, and solve for t and find that 3t is 75 while 2t is 50. So basically when you're going slow, you're going to take more time, 75 minutes, which is basically 75 by 60 hours, right? So without going into a linear equation, the one that we had earlier had a variable and multiplication brackets and all, you cannot manipulate this mentally. The prime advantage of the alternate approach becomes evident when you start, pushing yourself to solve paperless. It's very sequential in nature. Speed ratio 2:3, so time ratio 3:2, and these two numbers differ by 25, so they're 75 and 50. Either multiply the 10 with the 75 or the 15 with the 50 to get the distance. That is 10 km per hour into 75 by 60 hours. That gives you 12.5 kilometers. So you're making use of inverse proportionality to solve it in a what might seem like a slightly more complicated approach, but is actually way more efficient once you get the hang of it.